way to understand permutations and combinations is by solving as many examples as possible. In this example, we have been asked to arrange the letters of the word rock. In how many different ways can the letters of the word rock be arranged? We have one word and we need to rearrange the letters to form different arrangements. As rock has 4 letters, let's make 4 slots. What exactly are we asked for? In how many ways can the letters be arranged? We can form arrangements like ORKC or CROK or KORC and so on. How many such arrangements can we form? If you have gone through our previous sessions, you would immediately realize that this problem is no different. It's like we have been given 4 different digits and asked for the number of 4-digit numbers that can be formed. Do we have any condition here? Nope. We have simply been asked for the number of possible ways in which these letters can be rearranged. So we can start from anywhere. Say we start with the first slot. In how many ways can the first slot be occupied? The word rock has 4 letters. So the first slot can be filled with any of these 4 letters. 4 ways. Now, having filled the first slot, in how many ways can the second slot be filled? One of the letters has been used in the first slot. 3 remain. The second slot can be filled in 3 ways. If we have used an O in the first slot, then we can use any one from R, C and K for the second slot. If we use a C in the first slot, then any one from R, O and K can be used in the second. Now, having filled the first and the second slot with 1 letter each, in how many ways can the third slot be filled? 2 ways, as just 2 letters would remain. And the fourth slot can be filled with just 1 way, as 3 letters have already been used up. 4 ways in which we can fill the first slot, 3 ways in which the second slot can be filled, 2 ways in which the third slot can be filled, and after having filled these 3, only 1 way in which the last slot can be filled. As we are filling the first and the second and the third and the fourth slot, we multiply these 4 numbers to get the answer. 24 different ways in which the letters of the word rock can be arranged. And this is also 4 factorial. You could have written this answer directly provided you've understood how we arrived at it. The number of arrangements or permutations of n distinct objects is n factorial. Indirectly, this question asked us for the number of anagrams of the word rock. And this includes all the meaningless ones as well, like OKRC, KROC and so on. So this was easy. Now let me ask you a similar question. How many different anagrams of MOOC can be formed? Mooc stands for Massive Open Online Courses. How many anagrams like MOCO, COOM can be formed using the letters of Mooc? Try it out and we will see the solution in the next session. In the previous session, I had asked you to find the number of different possible anagrams of Mooc. Can we solve this using the same concept we saw in the previous session where we made 4 slots? Let's try. As there are 4 letters, the first slot can be filled in 4 ways. After using up 1 letter here, 3 remain for the second slot. 3 ways in which the second slot can be filled. After using a letter each in the first 2 slots, 2 remain for the third slot. 2 ways in which it can be filled. And just 1 letter remains for the fourth slot. And we multiply these to get the answer. 24 ways in which different anagrams of Mooc can be formed. 4 factorial. What we saw is incorrect and a very common mistake made by students. The important thing that we need to observe here is that there are 2 O's in Mooc. 1 M, 1 C and 2 O's. So what if there are 2 O's? Will it matter? To understand this, let's assume for time being that the 2 O's are different. Let's call them O1 and O2. Assuming they are different, let's look at a few anagrams. One would be M, O1, O2, C. And another one would be M, C, O1, O2. Now assuming the O's are different, can we write the first one as M, O2, O1, C? Yes, we can, as the O's are assumed to be different. And we can write the second one as MCO2O1. Look at the first pair. In reality, are they different? Is Mooc different from Mooc? No, they're the same. The two O's are not different. There is just one O in the English alphabet. What about the second pair? Is MCOO different from MCOO? No, they're the same as well. This is what 4 factorial includes. It counts each anagram twice, which is incorrect. Why is 4 factorial counting each anagram twice? The answer to this question is important. So let me have your complete attention for the next 1 minute. Assuming the O's to be different, there are 2 factorial arrangements for each anagram. The 2 factorial arrangements for each anagram are O1, O2 and O2, O1. But should we count 2? Are the O's different? No, they're not. So we should count just one of each pair. And that is why we should divide all possibilities by 2 factorial. 4 factorial includes all possibilities assuming each letter is distinct. But here, the 2 O's are not distinct. So we divide 4 factorial by 2 factorial. Many books will simply ask you to divide 4 factorial by 2 factorial as these are 4 letters and out of these 4, 2 are the same. But you must understand why we are doing it. In the all possibilities case, each anagram is counted 2 factorial times, so we divide it by 2 factorial to eliminate the repeated anagrams. What if we had another row? Something like Mooc? It's easy. How many letters do we have in all? 5. So 5 factorial will include all possible anagrams assuming the O's are different. But we have 3 O's here. So to eliminate the repeated ones, we divide 5 factorial by 3 factorial. So here's another one which I want you to try. Find the number of different anagrams possible for the word excessive. It's simple. How should we go about an anagram problem in your exams? The previous method we saw would be a bit tedious. So here's an easier approach. The first thing we should do is count the number of letters in the word. Same or not, just count them. 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 letters. The word excessive has 9 letters. Once we count the number of letters in the word, we should check if any of the letters are repeated. So let's go letter by letter. The first letter is E. How many times does E appear in the word? Do we see more E's? Yes, there are 2 more E's. It appears 3 times in all. Now we can move on to the second letter. It's X. It appears just once. What about C? Just once. E is already considered. S, it appears twice. S appears 2 times. I and V appear just once. And the last E has already been considered. Once this is ready, getting to the answer is very simple. 9 letters, so all possibilities assuming all letters are distinct would be 9 factorial. The letter E appears 3 times, so we divide this by 3 factorial. And as S appears twice, we divide it by 2 factorial. This is our answer. If you solve it, you will get 30,240 as the number. But you wouldn't really need to. The answer choices you would have in your exams would most probably be in the factorial form. So we can have these many anagrams of the word excessive.